Okay. Okay, we're ready to go.
Is it a rhetorical question, Pierre?
A rhetorical?
Yes.
No, I think it's a deep question that
Okay.
needs to be thought upon.
Am I still doing the introduction?
Sure. Yes. So, hi everybody. I will be hosting because Andrea is a big sick. Just close the window. So today we have a very exceptional seminar by Pierre, who has been involved in QISS in all sorts of ways since the beginning. He did his PhD in Marseille at the Center for Theoretical Physics with under the supervision of Carlo. And then he continued for a postdoc in Penn State. And very recently, a few months ago, he was accepted at some special program that Pierre is going to explain of the École Nationale d'Administration, which is a very prestigious institute in France that trains high public office professionals. So we all hope that in a few years, Pierre will be ministère de l'Éducation, et pourquoi pas Premier ministre même. And I should also say that Pierre is a good friend and collaborator. It's sad that he made this decision, but also knowing him, it's very fitting to his personality, I think. And it was obviously a conscious decision because he, at the same time, pretty much, he also got a Marie Curie fellowship, which he refused in order to continue with his new path. And Pierre, whenever you're ready.
Thank you very much, Marius, for the very nice introduction. Hi, everyone. I'm very glad to be given this opportunity to talk to you. I don't know how we should call it such a seminar. Is it like a posthumous seminar, maybe, or whatever? But it's going to be a bit unusual because I'm not going to talk much about physics, but I will talk a bit about physics. And so I have found this catchy title, Can French Administration Be More Sexy than Quantum Gravity? So Andrea, switch, please. Yeah, so until last December, I was a researcher in quantum gravity. Switch. And suddenly I announced that I was leaving academia to enter l'INSP, so Institut National du Service Public. And this is a school that trains the top executives of the French administration. So the big question that I was asking myself and that the other were asking is why? Why did I do such a thing? And indeed, French administration is a bit looking like that in the mind of many people. It's bureaucracy, it's paperwork, political compromission, it's an irrational process, it's centralized. While quantum gravity looks a bit more like this, you know, so it's like the coolest thing on earth. People discussing freely about very wild subjects, complete freedom, like the dream of all researcher, pure thinking, no compromission whatsoever. And okay, so what's the point? Many people asked me the question, and it was difficult for me to give a sensible answer. And each time, basically, I was coming up with a new answer. So switch, yeah, these are many different proposals for an answer to that question. Why? First is I passed the exam by chance and I randomly decided to accept the opportunity. Another is it is the most effective way for me to fight against climate change and for social justice. I'm bored with physics and I need a new adventure. My pedigree was too straight and expected, and I need to make jokes with life. I had no job security, and so I took the most secure position. I wanted to test many worlds with a big split in my life, which is the result of social forces and just part of the great resignation. And last but not least, I found a better way to quantize gravity. So now there are several questions I would like to tackle in this talk. Next slide, Andrea. These are the answers. These are big questions. These are big questions, and I will not be able to give answers, of course, but I will just be able to think about these questions a bit more. So, is there a life after academia? How to enjoy your PhD? How to wisely ignore the literature? How to win a Marie Curie fellowship? How to fund research? What have I really learned in physics? Which articles would I still like to write? And how will French administration quantize gravity? So let's start. Is there a life after academia? It's the easiest question with the shortest answer. Yes. Okay, this is clear. But for some reason, it's not always clear when you are in academia. And I know that this question is a source of anxiety. And I see several reasons for this. One is job insecurity, because there is a lot of job insecurity inside academia. This, we know it. And this is repeated and repeated ever since I entered university. I was told, you know, it is very, very difficult to get a position in academia. And so it's repeated ad nauseam, to the extent that it's becoming a very stressful element. While actually, if you think outside academia, for the people who have a PhD, for instance, there is absolutely no job insecurity. Like inside academia, yes, but once you have a PhD, it's very easy to get a job in many other things, many other directions. And so there is job insecurity. We should maybe stop being so stressful about this, because there is a life after academia and there is a world outside academia. Another source of anxiety is because there are very high social expectations about research. You know, it's very socially valued because it's fantasized as the realm of pure thinking and the world of science, especially, you know, physics. You talk about stars, you talk about the quantum, and there's a lot of fantasy which is coming from lay person, people who are not scientists themselves, but they just value a lot socially. And somehow the scientists, then they feel the burden of this dream, and they don't want to disappoint the people of this dream. And last source of anxiety is the ignorance of other jobs. There are just plenty of other jobs which are just as fascinating as researcher outside. But okay, the reason for people being a bit depressed about job is because there is a graph. So next slide. Yeah, you have this graph, you know, which is showing the evolution of a student expenditure in France. So we see that the total budget for higher education in France in the last 10 years is growing up. It's going up. But the number of students at university is growing even faster. So that's actually the amount that the state is investing per student is decreasing. And so, yeah, that's one of the reasons we feel more and more this pressure of it's just one illustration. It's in France, and maybe we should look at global figures. But one of the objective reason for why we feel more and more this job insecurity. Okay, next slide, please, Andrea. So how to enjoy your PhD? I see it depends so that's mainly for the students who are following this talk. So I see mainly 3 good reasons to do a PhD. Some people do PhD to get a position in academia. some because they want to do good physics, and some because they want to have a good time. And these are three different reasons to do a PhD. And I think and these are different reasons. It's not following the same thing. And personally, I think that to have the best PhD possible, you should aim at being somewhere here, somewhere in between doing good physics and having good time. And don't be too much afraid of not having a position. Have fun. In a sense, yeah, if you really, really want a position, don't focus on it. It will come later. So then I would say take your time and don't worry about producing results. I think this is something which is very stressful for students, the idea that they should absolutely produce results. And by doing so, somehow they lose faith in physics, in knowledge, and don't focus too much on this. I think academia is becoming more and more aware of the fact that we should not evaluate the people based on the number of publications that they have, and more hiring process don't really care about the number of publications that you have, but rather about the quality. And so I think there is something which is changing slowly, and we should continue in this direction. Next, don't do numerics if you don't like it. I know that somehow I have many friends, and I've seen many PhD students doing numerics because they were asked to do it sometimes. And in a way, it's an easy way to get results, that things that you can show, that you can put your hands on. But also, I think if you don't like it, just don't do it. People, when they start doing physics, usually it's not for the numerical studies that they can do. And so sometimes it was not at all my case during my PhD. And so I've been very lucky about this. But I know that sometimes PhD supervisor use their students as a cheap way to do numerics that they don't want to do themselves. And sometimes I feel PhD are a bit wasted that way. Okay, next, go to summer schools. These are personally the best experience that I had during my time as PhD student, and later also just going to summer schools and learning in a nice atmosphere. Next, and take breaks. Yeah, take breaks. One of the best thing that I've done is that right after my PhD, I did not went right into my first postdoc. There was a gap of about 4 months, and during these 4 months, I just stopped doing physics completely. And that was really great, because when I was back on my first postdoc, then the motivation was very high, and I had refueled myself after being a bit exhausted by the PhD. And so taking breaks is, I think it's absolutely not a waste of time. Next question, how to wisely ignore the literature. I think for many scientists, the literature is a burden, because there are so many articles which are published every day. It's becoming mentally a bit stressful to feel obliged to catch up with the literature. There are too many new articles. Many of them are badly written. It's very, very difficult to get into them. There are too many keywords which are used without any explanation, and you cannot find any definition for these keywords. And too many references. So when you want to dig into something, then you're easily lost because you have hundreds of references and you don't know where to start. And so I think, in a way, one should. So yeah, these are illustration. Yeah, good. Yeah, this has illustration of, I think, a problem that we have. This is the exponential growth of papers which are published every year. So on the left, it's the papers which are published on the archive. And it's really exponential. So in the last years, the exponential was mainly due to computer science, which came into the game. But if you focus only on the two categories, which are quantum physics and general relativity and quantum cosmology, you also have a growth. Like 10 years ago in quantum physics, there were twice less papers as there is today, which are published every month. So, and the growth is growing and growing. And so I think we should worry about where is this going? What's the right strategy to catch up with this? Because it's not possible to catch up with everything. And next slide, Andrea. Yeah, there is a quotation that I like by Einstein, which is the following. This is while he was trying to devise general relativity. And he said, I am not able to acquaint myself with everything published on the subject because the library is closed during my free time. And so the fact that he was physically, could not, for schedule reasons, could not access to the literature somehow was also a nice way for him to ignore the literature and to focus on the thing that he really wanted to do without caring too much about what the people were doing. And so in a sense, maybe we get some inspiration and not try to catch up with everything, but have other strategies. And one of the strategy that I think I would recommend is to read more old papers. There are many old papers which were published like 20, 30 years ago, which are known because then the name is known, they are cited many times, but they are hardly ever read. And probably they should be read more. That's the first thing. The second thing is to write better papers. I think it would be, it's a problem which is a bit systemic, but I think, and so I don't believe so much into individual behavior to change this, but to some extent, individual behavior matters. And I think scientists should just spend more time to write better papers. And so, for instance, don't publish a paper if ChatGPT could have written it. You know? Now, if you should really think carefully about each sentence in a paper, then always ask yourself whether your paper can be more clear and shorter. Don't write something in a paper if you don't understand precisely what it means, and keep only the essential references. So this, I think, is a bit difficult in the community because for some reason, everyone wants to be friend with everyone. And one way to be friend is to cite each other. And I think, yeah, there's of course a nice aspect of it, but it's also problematic. And personally, I think that we should have another ethic, and the ethic would be try to limit the number of references to only what is really essential, because otherwise the references are not useful anymore. And I know that there are many papers which start by loop quantum gravity is a way to quantize gravity, and then brackets, and you have 100 of references in it. You know, you cite everything which has been said about loop quantum gravity. And I mean, I don't like this way of doing, because then what's the point of references? I think we should always keep in mind this quotation by the mathematician Atiyah, and he was saying that the aim of theory really is, to a great extent, that of systematically organizing past experience in such a way that the next generation of students and their students and so on will be able to absorb the essential aspect in as painless a way as possible. And this is the only way in which you can go on cumulatively building up any kind of scientific activity without eventually coming to an end. I think this is the true solution to the exponential growth of article. If we try, I mean, if we want to fight against this exponential growth, not being drawn by it, we should focus on being synthetic instead of being exponential. All right, next slide, please. Yeah. And so otherwise, yeah, how to make the whole system of publishing better? I think in the next 10 years, the goal of all physicists should be to ruin commercial publishers. And the good news is that there are now very good tool to do it. It's to promote other journals which are on a diamond open access model. And in physics, we have such journals. There's Quantum, there is SciPost, there is Philosophy of Physics. So now the tools are there, and we should now start to forget about Elsevier, Wiley, Taylor, and Francis. This, I think, is really essential. Then, more anecdotically, I think we should get rid of rigid categories like quantum physics or GRQC, and go more towards a model where you don't need to specify in which your category your article falls in, because you have very efficient tools like iarchive.org, which are able to analyze how papers are close to one another using keywords. And I think this is much more effective than these rigid categories. Then we should work a bit on the way, on the different formats for publishing papers. PDF is like the original way to do it because it mimics the papers that we have in the physical world, but we should try to make it more convertible to other formats like HTML or LaTeX to be read on any support. Then I think we should try to make Wikipedia better and to consider this as part of the job of scientists. Many scientists are already doing it, but because it's not valued, you cannot really say that you are the author of such an article. Many scientists also don't spend a lot of time doing it because you don't really get the price for doing it. But Wikipedia, I think, is just a wonderful tool, and many scientists are already using it. And we should try. I think it should really be the central platform where scientists start to write technical and precise articles. Then I think we should make versionable articles like softwares. It's somehow a bit the case already because on arXiv you have the possibility to make different versions for your article, but I think it's not going far enough. I think we should start thinking the possibility of making articles and then adding full sections, full new sections which complete it to build on top of it, and so that really articles grow themselves instead of adding more and more articles. Yeah, that's one thing. And finally, we should replace the peer review system by some kind of overlay system with stems. I think the peer review system as it is now is a bit outdated. It's not at all adapted to the internet and the digital tools that we have. Okay, let's switch to another question. And Andrea, if you can switch, yeah. So how to win a Marie Curie fellowship?
Yeah, can I interrupt real quickly? What do you mean by stamps?
I mean some kind of labels. You know, for instance, instead of so nowadays in practice, this is what it is. When you make your article being peer reviewed by Quantum is just somehow putting a stamp on your article saying it has been peer reviewed by Quantum. I think we should imagine a similar kind of system, but you could on one article you could have several stamps. So, for instance, you could have the stamp of Quantum, but you could also have the peer review by another journal, and you have another stamp. Because what is the value of a journal? A journal can evaluate a paper according to many different kind of criterion. One important criterion is to check that something like scientific method has been followed. That's one minimal criterion. But another criterion could be scientific validity, which is not exactly the same thing, you know, because you can be right on the method and wrong on the conclusion. But another criterion could be just pedagogical. Is it clear enough? Is it pedagogy? Some other could be, is it very original? Is it completely new paper? And depending on which journal you choose nowadays, you have a different combination of these criteria. And I think that these criteria should really be made explicit by each journal. And then an overlay system for the peer review would be a way to put stamps that would tell you directly, okay, this paper has been recognized as being pedagogical by such a journal. It has been, etc., etc. Yeah.
Thank you.
So now, how to win a Marie Curie fellowship? So I was lucky enough to win the Marie Curie fellowship and to decline it. But the reason is not because I'm a good physicist, but it's precisely because I'm a good administrator. I'm a good politician. Okay, and so if you want to win a Marie Curie fellowship, the first thing that you have to do is to read many, many pages of rules. And you have like 3 documents that you need to read, which are it's really many pages. It's very, very boring. You have to read all of this. And then you have to create your own document, which is 10 pages. And okay, I really think that all this process is absolutely, completely ridiculous and should be changed entirely from A to Z. So this is the example of the first paragraph of my own application. And they ask you to start with a part which is called excellence. And so from the very beginning, you're asked to explain why your project is excellent. And notice that at no moment you are asked to describe what is your project. The first part is quality and pertinence of the project's research, but you don't have yet described the project itself, but you are already asked to describe why it is relevant, why it is high quality, why it is excellent. So this is a sign that it has really been devised, and not by physicists, this procedure, but by people who want to evaluate. At any rate, they want to evaluate your work. Then a bit later in the proposal, the second part is the impact. So in the impact, you have to start lying about what you want to do. So this is what I have done here by writing my career goals. So you have to say things in which you don't necessarily believe, but this is just a formal exercise. So I dream of getting a CNRS research position in my home country, France. This is the first sentence. And it doesn't really matter if you believe in this concretely. 3 months after writing this sentence, I left academia. But this is the way it works. And then you have to put many keywords everywhere that needs to be checked. So you need to talk about career strategy, about research autonomy, about building a unique research profile. All this is just blah, blah. And it's better to do political science than physics if you want to write a good Marie Curie project. Next, to give another example, you have this very funny thing, which is the implementation in which you have to, so you are forced, this is in the rules, you have to write a Gantt chart. And this Gantt chart, and I had never heard of it before, is like a completely fake schedule of what you have to do, of what you are going to do in the 2 years of the proposal. And so it looks very professional because you divide your work into work packages, it's abstract, and then you put many colors because it looks good. It looks that you have thought about it very deeply. But of course, I think everyone, all scientists who do this thing, they know that the first day of your proposal, this Gantt chart is going to go to the rubbish. You will never apply it. And last example, Andrea. Yeah, then you have to talk about risk mitigation. So during all your project, you have to explain why you are very good at this project, why it is very relevant project, and at the end you have to explain why there is a risk, but and how you are going to mitigate this risk. But of course, the truth is that you have absolutely no control on this, and you know that your project is going to be completely different to everything that you have written before. You know it when you write it, but you have to fake and to fake some kind of risk control, which I think is absolutely impossible. So the conclusion of this is that to win a Marie Curie fellowship, you better be like more like a salesperson. You need to oversell yourself, your vision, your project. It's very good to copy paste on other successful applications because it's really about keywords. You need to make sure that all keywords are present. And maybe now you can try to use ChatGPT. It could be even you could waste time. So I think here in this is an example of a big problem that there is, I think, in science in the way it is funded, because the Marie Curie fellowship, in the way it is done nowadays, it is wasting the time of scientists, because I have spent like 3 weeks writing this proposal, a waste of time. Then it teaches scientists to lie. It's really against the ethic of any scientist. Then I think it causes disgust for the project themselves, because when you have tried to pretend that your project was very strong, at the end of the 3 weeks of thinking about it, you realize that maybe your project is not so good, but you will submit your project anyway because now it's done. It wastes the money of taxpayers, not only because it uses badly the time of scientists, but also I think the money that you get when you get the proposal is too high. Like, you have a paradox that it is very difficult to get money to do science, but when you get money, I think the salaries are too high. The salaries of people with a Marie Curie fellowship are too high. You could split it in two and have 2 projects. And finally, Marie Curie fellowship is completely ignorant of the way research is done. So this raises the next question, which is, if we have a problem with research funding, how should we fund research? The common conception about this, I will not give a definite answer of this question, it's very difficult, but I will try to be a bit going to the root of the problem. So the common conception is that there is finite resources, it's money, and it needs to be allocated in the best possible way. And one way to allocate it is to use competition, evaluation, short-term projects to select the best possible research. And this is like a paradigm of a new public management. And to some extent, there are many good reasons for why it should work. But of course, well, we should understand what is the best possible research. Well, the best possible research depends on your motivation for doing research. And here we have a discrepancy between the motivation of the people who fund research and the researchers themselves. Because the people who fund research, like the Templeton Foundation, what's their motivation? Well, for the Templeton Foundation, for instance, there is a strong ideological hegemony. They have a political, ideological program, and so they are going to give money to researchers, not necessarily to work directly to prove that God exists, for instance, but it's a bit, they are going to fund research which has a priori nothing to do with this, like quantum physics, to give themselves some credibility and to look very nice and to be able to build slowly some brand. And of course, it's useful for tax reduction for other reasons. The European Union has a different goal, which is competitivity. So they think that research is going to bring technological breakthroughs. And so that's why in the Marie Curie Fellowship, you are always asked to show why quantum gravity is going to bring technological breakthroughs, which, okay, no one knows. The researchers, the reason for which they do research is very different. They do it because it is interesting. and it can sound very vague, but it's interesting. It doesn't mean much, but it says the essential of it. It is interesting. It brings some interest, and that's enough. And so I think the right way to tackle the question of research funding is a bit different. Next, yeah. So the question to ask is, do we have enough resources to do something interesting? First of all, money is not the resource. The resource is human work. And money is just a tool to allocate this resource. So this conceptually is very important. The resource which is actually doing the job is human work. It's not money. Money is just like a way to help reaching the goal. Then we need to make sure that all needs are satisfied. Food, water, whatever. And doing something interesting, like science, is a human need. And so then the question is, how do we satisfy all these needs? And then it becomes a question of power and not anymore of money. And I think that's the main message that I wanted to say here. That the debate about research funding is not a question of money. It's a question of power, meaning who decides what should be the research which is done. And I think what is problematic, for instance, with the Templeton Foundation, it's not that they give money. This is not the problem. We are happy to have money to do research. But the problem is that it is a private foundation which decides what kind of research can be funded. I think this is the main problem about it. And here you have a chart about productivity, just to show that in the last 70 years, like productivity has been multiplied by 3 or 4. And so we have a lot of resource. There is a lot of free time which can be dedicated to fulfill new needs. Okay, next slide. Okay, now we are going to physics. There are many questions in this talk. It's going a bit in all directions. But anyway, I wanted to use this time a bit to think about what were the big lessons that I have learned during my time in academia. And I think these are 5 key ideas in physics which I have learned and which are really important. So the first, I think knowing a bit of category theory will help you learn faster and on a wider range of subjects. And this, I realized it in a very good paper by John Bez, which is written here. So first idea. Second idea, I think if you should adopt a relational perspective on physical entities and quantities. This has been one of the deepest aha moments of my time in physics, and there is a very good paper. It's not the original one, but I think it's better, by Carlo. Third idea, it is better to think of phase space as a space of solutions of equations rather than a space of initial data. So to me, this was very, very powerful, because when I was at university, I learned phase space as being a space where you have initial data, and then the Hamiltonian gives the evolution over this phase space. But then by reading this paper of Witten and Knovic, and also other paper by Souriau, I realized a big problem with the usual conception of symplectic geometry, which is that it is not in accordance with the principle of relativity, of Galilean relativity. And if you want to make it in accordance with Galilean time translation, then you should think of it covariantly. And the covariant way is to think of the space of solutions to the equation of motions. And I think this is really, really, really powerful. Fourth idea, the difference between classical and quantum mechanics can be located as a lack of associativity of observables and the existence of a metric on the space of states. I discovered this in in a paper by my friend Federico Zalamea, but actually it goes back to ideas which were developed by Lanzmann and also Abay Ashteka and Schilling. And I think it's a very nice geometrical way to understand the relation between classical physics and quantum mechanics. So these are the four ideas that I was able to identify as being very, it's bringing a lot of emotion when I think about them. So which articles would I like to still like to write? So I left academia a bit suddenly, and there were some things that I had in my mind and I would have liked to do, but I had no time to do it. And so I'm going to present research which is not done yet, but it's just the title and a short abstract of what it could look like. So maybe it's completely bullshit, but I'm taking the risk just for the fun of it. So the first paper would be called an anti-system pamphlet. And it will explain that the notion of system in physics is misleading. And because it relies on false preconceptions on the nature of reality. And so we should try to formulate physics without the notion of system, which of course is very difficult because you have sometimes what is presented as the first axiom of quantum mechanics, which is to say the world is made of system. But I think such assertion is problematic in many ways. The second paper that I would like to write is Understanding Laurent Fredel. So this would be a pedagogical introduction to edge modes, local holography, relative locality, and subsystems. Because in the last few years, I tried to understand his work, and I thought it is very fascinating in many ways, but I'm having a really hard time understanding it. And I would have liked to spend more time on this to be able to make it clear in my mind and being able to explain it very clearly and precisely, because I think there is a very nice research program going in this direction. The third paper that I would like to write is why quantum gravity has already been measured in the sky. And so this is following discussion that I had with Eugenio Bianchi, where he explained me and kind of convinced me that by measuring the power spectrum in the CMB, there were measurements implying G and H bar, which could be interpreted as a measurement of quantum gravity, at least in the same sense as what we have in the BMV experiment. And I think nice to see this in cosmology, and maybe it's not known enough in the quantum information community. And that's something that I would have liked to look at. Third paper, it would be called no-go theorem. And it will basically argue the following, that for any no-go theorem in quantum mechanics, the three following propositions are incompatible. The assumptions are conceptually clear and reasonable. No crucial assumption is left implicit, and the proof is understandable by a Newton. Okay, that's because I had the feeling that in quantum information, since the success of Bell's theorem, everyone wanted to cook their own no-go theorem. It's a very effective way to formulate things, that's true. But somehow, whenever I try to look very carefully in the details of the theorem, I was always very disappointed by one of the three aspects which are there. So it was somehow a meta theorem. And last, a paper which we call Kill Bell, like an homage to Tarantino. And it would be my final take on non-locality. I thought a lot about non-locality, and I'm still confused by what is the deep meaning of it. But when I left academia, I was approaching some kind of stable opinion on it, and I would have liked to make it more explicit. And it would be something along the following lines. The need for locality comes from mechanical philosophy, but physics teaches that space-time is not a natural stage of dynamics, but phase space is. And so it is enough to have a notion of locality in phase space, even if it projects to non-locality in space-time. And of course, the question then is, what is this notion of locality that you could have in phase space? Because just in phase space, you don't really have a metric. You have so what could it be? Okay. Next slide, and almost finished. How will French administration quantize gravity? So I'd like to come back to a very good book, which was written by an historian, Jean-Pierre Vernant, which is called Les Origines de la Pensée Grecque. And in this book, he's trying to think about the origin of Greek thinking and rational thinking. And this book was written because 10 years before, the archaeologists have been able to decipher the linear B, which is a system of writing which is used in Mycenaean Greek by the Mycenaean Greek. And by deciphering this writing, they were able to understand better this civilization. And this is a civilization which collapsed at the 12th century before the Common Era, at the end of the Bronze Age. And by discovering this civilization, they realized that it was very different from what was described by Homer in the Iliad, for instance. Because Homer, when he's writing the Iliad, it's 5 centuries later. And so the world has changed radically. And when Homer is describing the Mycenaean world, it doesn't match with archaeological evidence. And from this, Jean-Pierre Vernant is trying to understand, to say this is that in between, there has been a transition from the mythos to the logos. And this transition has first happened in the organization of the cities themselves, in the social organization. And then it has been translated into the conception about the cosmos. And this is the emergence of science. So initially, you have a new social order of the polis, so the city, which is characterized by a preeminence given to speech, with the emergence of a public domain and political equality. So you don't have anymore a king which is at the top and at the top of the pyramid. Such the organization is different. Now you have citizens which are equal. You have some kind of democracy, and you have a public domain where people can debate and exchange ideas. And first, this is happening in the political scene. It's a matter of administration, of laws. But because there was this social organization, Jean-Pierre Vernant says, it has pushed the people to think about the cosmos differently. Now we are able to think the cosmos in a way which is more geometrical, which is based on laws, which are it's not because of the gods, but it's because of laws which are without sacred character. And I think this thesis is very interesting because he says, I mean, it is a crucial, we all know, but this is very precise, that the way we shape a society has many consequences on the way we think about the world, about the way we do science. And another example of such a thing, I think, is a bit later, Andrea, of course, is the Copernican revolution. We call the Copernican revolution like that, but maybe we should call it the Columbian revolution. Because in a sense, there has been about at the same period 3 revolutions, with the discovery by the European have discovered America. Then there's been the new system of Copernicus, and also the Protestantism of Luther. And all this comes at the same moment, and in a sense, that's another example. Copernicus is allowed to think differently because the social context has changed. Okay, so that's finally the school that I have entered. It's called the Institut National du Service Public. And I hope in some way that I will be able to contribute to create a better environment for science and for quantum gravity in particular. Formerly, it was called l'ENA, and it was created right after the war with one goal, which was to reconstruct France, because it had been destroyed by the war, and there were big challenges. And nowadays, l'ENA has changed, becoming Institut National du Service Public, because there are new new goals which are a bit different. There's the ecological transition, the numerical transition, and also I think there's a transition in science which is happening. And so I will try to contribute to it in a nice way. And so far I've been spending 4 months at the French embassy in Gabon, and I think this was really a sexy experience. You can switch a slide, Andrea. These are just some pictures of my last weeks. Thank you for your attention.
Thank you, Pierre. Yeah, it was a very nice talk. I wanted to say, just as a first comment, that 5 papers are not a lot to write on your free time these next years. And I hope you do that. So any questions or comments, feel free to Carlo raised hand. Carlo, please go.
Just a small comment. I want to thank you, Pierre, because this is a very nice and warm, but also extremely interesting reflection, set of ideas. I think they're very meaningful for a lot of young people, but also for the old people like me. And I'm going to think about all the things you said. There's a lot to digest and elaborate here. About the future, I only hope we remain in touch.
Yeah, I hope it as well. Thanks, Carlo.
There's a few hands. I didn't see who was first. Sorry. I just go with the order in the chat. Hal?
I have to run to a student meeting soon, Pierre. So I just have a silly comment for you because I also really enjoyed the talk. My first year in college, I took a humanities course, which was supposed to be a survey. And we read Vernant's book, The Origins of Greek Thought. And I had it near my bedstand, and every night I would try to read it, and I'd fall asleep after 3 sentences. So I'm overjoyed that you love this book, because I couldn't get through even a paragraph of it before I fell asleep every night. So
you should try again.
I should try again.
Yeah.
It's no comment on Vernant, although I think the language was kind of dry.
Yeah,
Thank you. Such a nice talk.
Thanks. You should try in French, maybe. It's very well written in French.
Let's go to Deepak.
Yeah, so hi, Pierre.
Hi, Deepak.
Mentioned to you in my mail, it's a big loss for our field that you're leaving, but perhaps it will turn out to be a big gain in the future in some way. And incidentally, at the same time, the young researchers of quantum gravity had organized introductory talk on celestial holography. But I started watching that in parallel with this talk, and yours was much more entertaining. So I stayed here. And yeah, I mean,
Thanks,
all the best with everything, So.
Thank you. Good luck to you. Good luck to you.
Thank you, Deepak. Ding?
Thank you. Hi, Pierre.
Hi, Ding.
Hi. I have maybe 2 comments. I try to keep them short. First comment is on how to make a living. If one wants to do physics, fundamental physics for fun. Like you, I face a lot of job insecurity, so I spend some time gathering random thoughts on, how to keep on doing physics and getting paid. Here's one thought I want to share. the inspiration comes from gamblers. There are people who bet on soccer matches, people who bet on sports matches. They think they can make a profit, gain money out of some of them, out of their knowledge of the game. So I'm wondering whether we can similarly, make our professional skill pay off by betting. Here's a possibility. For example, if I'm doing research in quantum gravity, I don't believe in ADS-CFT correspondence. There are a lot of people that do. So we can propose a bet with them. Say, what's your confidence that in 5 years you can prove ADS-CFT correspondence to be right? Or we can prove ADS-CFT correspondence to be wrong as a description of our universe. And then people can state their confidence levels, and then we can try to come up with some bets. Maybe we can even come up with these bets on some online platform, like a website, and this opens up different possibilities, like calling on people. If you're really serious in your research, why don't you bet with us? And that way, maybe we can gain a little bit of extra income or a little bit extra expense or more. I don't know. That's one thought I gathered. So something like a random thought. Another comment / question is you mentioned you want to write a paper on Laurent Friedel, a pedagogical paper on Laurent Friedel's work. I'm looking forward to it because I try to understand the motivation for this program, and I haven't been able to. It's not clear to me what the question is in fundamental physics that this program is trying to solve. And if you have comments now, or if you will write about it, I'm interested.
Yeah, unfortunately, I'm not sure that I will have time to write a paper that I would like to write, at least not in the following months, maybe later. But of course, I would be very happy if you were writing this paper, and then I could just read it afterwards.
The problem with me is I find it difficult to understand this program. What's the motivation?
What are the motivation?
Yeah.
Yeah. Well, I think the motivation ultimately are still to quantize gravity, but it's doing in a way by working a lot in classical theory and trying to understand things that were not really understood before. But yeah, it's not clear myself. But if you are interested in this, that I think we can. I mean, I'm glad to spend an hour with you trying to discuss about it. Just to, yeah, I will not engage myself in a project about this, but since I already started to think about it, I'm happy to take some time discussing with you someday.
I'll write an email to you.
To tell you, yeah, sure. And about your first comment about gamblers, okay, that's very wide proposal, and that's funny to think about it. Then the difficulty we have in science is then we don't really have a judge that decides what's right and what's wrong. And so suppose we make a bet between you and me about whether we are going to prove something in 5 years. Then maybe in 5 years we will disagree whether what I've done is a proof or whether it's not.
I thought a bit about this.
We don't have a judge. We don't have a judge to say who's right.
The website can have 2 or more sections. One section is betting with people you trust. You just decide on your own between the 2 parties. If the other party says I don't want to pay, then you agree with this in advance.
Okay.
That's one section of the website. The other section is you nominate judges beforehand, and then in 5 years the judges decide.
Yeah. Okay.
In that case, you have to, of course, there's human part of it, but yeah, these are some thoughts I have on this point.
Okay. Well, I think, yeah, I see. But I think also this tackles can somehow tackle the problem of money, but it doesn't tackle the problem of power. And I think this was really the problem that we have. It's not a problem so much of money. Somehow we can get money. You know, I can apply to Marie Curie and I can get money to do some research. It's just very, very painful. And the problem is about the way it is decided. There is a lot of money for research, but it's very painful to get it. And you have to apply many times to short. And so it's really about power. Who decides how it is organized, more than a problem of money.
These kind of problems I haven't thought about, because I'm very far from being powerful. Yeah, but
Guys, sorry to interrupt. There's a few other people that are raising hand. Maybe we can proceed to them and come back to Dink later if you want.
sure. No problem.
Eugenio?
Hey, Pierre, it's so good to see you.
Hi, Eugenio.
It was really fun. Yeah. So at one point you were bringing up, go to summer schools. I can't agree more than that. And I just wanted to tell you, I'm sure that everybody already told you, but the school in Gutelas that you started was such a success, was so fantastic, and there was so much of the spirit that you're proposing. And yeah, I wish so much that you would have been there, and I hope that you got all the feedback from everybody.
Yeah, thanks, Eugenio. I'm glad this was.
Yes, for everybody else following, we had a fantastic school a few weeks ago at Gutelas in a castle close to where Pierre grew up, and Pierre had spent a couple of years intensely lobbying for us to do that. And when we went to the school, Pierre was skydiving in, where were you, in the Caribbean or something, right?
In Gabon. Yeah.
I was fortunate enough to see the photographs from that school on Twitter.
Let's go to Wolfgang.
Hi, Pierre. Hello.
Hi, Wolfgang.
Thanks for this really nice talk. So one thing that which I find a really interesting idea and really something to follow up is how to change the publishing system, and this idea, for instance, about stamps. And what I think is what we don't, I mean, in science, we appreciate trying new ideas, trying out new ways, solving old problems, and so on. This is how scientific progress works. But in the way we do other parts of academia, they are very conservative in a way. We do things just the way we always did it, and nothing really changes. So I think we should be really open to just try out things, especially in areas. I mean, there are good reasons why, for instance, in medicine or for instance, in medicine, when it comes to vaccines and so on, then it's very important that a system that just works and has worked in the way we evaluate research, that we don't change that. But in fields like in fundamental physics, I think we should be open to try things out differently, and ideas that work can go on, and we should not be afraid to make mistakes. I think another thing where I don't agree. You said at some point you were very critical about exponential growth in the number of papers that are being produced. I don't think that this may be actually something very good, because it just tells us that the whole world is that it's not just Germany, France, United States, UK that are producing scientific results, but there is something happening globally, that more and more institutions are producing research, and that's something good, I think. And for a similar reason, I don't think that private involvement in research is so bad either, for a similar reason, because if there are many, I don't believe in this idea that there's just one model that cannot fit everything, you know. And so if there are different ways for doing science, different ways for funding science, this is not bad, I think, because it gives room for different scientific questions. But that's just my point of view, and I'm glad that I could say that. Thanks.
Yeah.
Just wanted
Thanks
to,
again for the interesting talk and the many ideas to think about.
just wanted to add to what Wolfgang was saying, is that I completely agree that you know, it's like an ecosystem out there, and there should be many and diverse sources of funding, and you know, which compete against each other and which also provide greater opportunity to people looking for resources. So
yeah.
Maybe let's
Yeah.
let Pierre answer.
Yeah, on the funding, in some way I agree that there should not just be one model, but many different kind of model. But the problem I have with private funding is that it's anti-democratic. I think this question about what kind of research we should fund should be based on criteria which are democratic. It should be in the power of just a few people to decide what deserves money, what kind of research deserves money. And with private funding, it's just not democratic at all. And so that's a matter of principle for me, which is private. But if you accept the democratic principle, then of course you have many different kinds of models to fund science. It's not necessarily the state, it can be in many other ways. But I don't have a precise model in mind, actually. Many things can be thought. On the exponential growth, so it is true, it's partly true that the exponential growth is due to the emergence of new countries, which are publishing. Like if you just look at one country like France, for instance, you don't have an exponential growth. It's growing, but not exponentially, quite slowly. And the growth is coming from some countries, and that, in essence, that's a good news. It's also coming from the emergence of new fields like computer science, which are while other fields are constant in terms of publication. So if you look into the details, it's more subtle than that. But I think the problem that I'm describing is like we should wonder where is this going? You know, whenever you have an exponential, you should at some point wonder where is this going? Is this going to stop somewhere? How is this going to stop? What does it mean for the kind of science that you're doing? Does it mean, for instance, that the different categories are going to be divided into smaller categories in order for scientists to catch up? That's the specialization of science. And we know that specialization of science has been a big trend of the 20th century. But my intuition is that in the 21st century, we should try to avoid further specialization. But the way to do it, it's not clear how. But so, because I think that we should maybe, I don't know. Again, I don't have an answer, but I think that it's problematic it was at least a problem for me as a scientist to think that there were so many papers coming every morning. What am I supposed to do with this? And to some extent, that was part of the solution that I was proposing. You can just ignore it. You just put some wax into your ears and you ignore that fact. And you just do your stuff with your community, the people that you know. And maybe that's enough. But also, and that's what I was arguing. I think it should be an opportunity to rethink what we want to do by publishing a paper. A lot of this growth, exponential growth, is just due to the fact that institutions rate scientists on the basis of how many papers they publish. And so, for instance, it's better to slice your articles into many articles because it just takes a bigger figure. That's, yeah.
Thank you. Daniela raised hand. You're muted, Daniela.
Yeah. So thanks, Pierre. It was very interesting and stimulating and quite fun as well, which is a rare combination. So I want to play the devil's advocate. So I will do that after stating that I agree with, in fact, most of the things you said and most of the criticism about funding, about how research is going and blah, blah, blah. And not only I agree, but I could add more criticism along the same lines. And I guess sharing more or less the same goals and values. So having said that, and I hope that is taken for granted, let me problematize a little bit what you said. So, for example, I mean, concerning the fact that in research grant applications, we are forced not only to spend weeks or months preparing them, which is, of course, bad for us, but to add these useless things like workflows and work plans and risk assessment and all of that. I want to point out two things. First of all, that we should not be too much biased by the specific domain in which we work. Those schemes for grant applications and items to be filled and so on are very general, and it's in fact is a practically impossible to really differentiate the scheme, the template for the dozens of subfields that you could consider with different criteria and different different ways of working and different objectives. We simply lack manpower and resources to have so many reviewers and so many different types of schemes and so on. So what to us seems really strange, what is the workflow? How do I know how my project is going to look like in 1 year? Is I don't want to say absolutely necessary, but almost necessary in fields where you have to buy materials, grow some cell culture, or deciding which season you go and observe some bird, and so on. And that has to be carefully planned. Not only because if you don't do that, the project can go easily screwed and you just don't get any result whatsoever. But also because at the very least, you should show that you're able to plan like that. Then things can actually go differently. But part of the, evaluation of your grant application is this guy able to actually plan things and take into account all the complex factors, including timescales and things like that. And basically the same goes for the risk assessment. In fact, with the risk assessment, I think it applies even directly to us. It's not about predicting what will go wrong, because again, we have no idea, many things can go wrong. But you're asking money to somebody. In fact, your mom, your dad, if they're still working, they are basically contributing to your grant, and your friends as well. Now, they want to know what are the risks of failure for your project, whether you thought about them, and if you can forecast what are the more tricky aspects that could fail, that will more likely fail. And in case somebody goes wrong, do you have some backup plan? It doesn't mean that everything is planned, but can you think of what other strategy could you fold into if something goes wrong in the main research line? I think that's extremely useful and extremely important. We show that we are able to think in those terms because things go wrong. Again, it's a mistake to think that what they're really asking is whether you can plan everything that will happen in the next 2, 3, 4, 5, 10 years. But they want you to show that you can react. You have an idea of what could go wrong, and you have some ideas of how you can make things work anyway, so that it's not, a useless risk to give you money. So that's a couple of comments. Then on the research funding, there would be so many things to say. I mean, you said many interesting things, and I have several comments. I mean, one is that I just summarize things in one short comment. Although, once more, I agree with the spirit of what you said and with some of the ideas for how to improve things. The risk that we all in theoretical physics and in quantum gravity more can fall in is to take the attitude, hey, I do what I do because I find it interesting. You should pay me for that. Now give me the money. And it is that. I mean, because when you say, well, I don't need to show that, I don't want to show that I can produce many papers. Okay, fine. I understand why. And I agree. I don't want to claim that what I do will produce technology or something else. Okay, I understand that. I agree. But it sounds, it's a risk of sounding, and it does sound to my friends when I tell them, well, I want to do whatever I like because it's interesting, just I'm curious, and this stuff is cool, but I want your money, because these are the ones who are actually producing wealth, where the money comes from, with their, shitty jobs and less interesting day at the office, and less, intellectual inclinations. So, once more, I agree, but we should be very careful that things are a bit more complicated than that, and we should not fall into that type of mindset. This stuff is so cool, people should let a lot of people, as many people as possible do that, receiving money, possibly a lot of money, because it's a super important activity. So it cannot be paid, the minimal salary, because science is important. Somebody will have to work to give you that money, and you have to convince them. And so that's the related comment is that I get a little bit uneasy when you say just a matter of power. Because to some extent it's trivially true. Everything in the world is a matter of power. Who decides and who has the means to decide where to put the money, what to fund, what is more interesting, what is less interesting, and so on. So if you say we had to convince as many people as possible that what we do is so interesting that needs to be funded, that's exactly how in democracy it works, or supposed to work, then I fully agree. But again, the thing can be declined in a different manner, a bit like, the Plato Republic. The intellectuals take power. They know what is true and what is not. They actually benefit from the work of the slaves. And they are in charge. I don't like that. And it should be, it shouldn't be even some, ameliorated version of that.
Thank you, Daniele. Sorry to jump in, but that was a mini speech. Let's try to wrap up. Pierre, you have the last word. You reply to Daniele, and you can also conclude.
Yeah. No, thanks, Daniele. I think I agree with some of the things that you've said. When we need to buy big infrastructures, materials, yes, indeed, we should apply and think very carefully about the plan. But when it's just about your salary that will allow you to live decently, just to get food, to get a house, I think this is absurd to go through such a process. And this was the case, like for me, when I applied to Marie Curie, I was not asking for a lot of money. I was just asking money to get to be able to have food and a place to sleep. And the way you present the thing is the common way we present the thing, is to say there are people who are real workers. They're like in companies, they do real jobs, and they are producing economic value. And then there is a tax which is put on them, and this tax enables to pay people who are not really working, like scientists, and they are just thinking about what they want, and so the scientists should always be justifying themselves and saying to people, no, but you give me the money because I'm actually producing something. But I think this conception is wrong, completely wrong. I think it's very, very difficult to locate precisely where the economic value is created, because economic value that you can measure globally at a global scale in the form of the GDP, when you want to say which parts have you contributed to the GDP, it's almost impossible, if you want to do it carefully, to locate to one person and to say that person has contributed that way to the economic value. And so I think that scientists and physicists who are receiving a salary, not because some other people who are producing value accept nicely to give them some money, but because scientists are producing part of this value. So it's when I say that it's a question of power and not a problem of money, it's the power to decide what is the economic value. And that's it. Let me close on this.
Thank you. This is so nice. Let me just say something to give you the ball to conclude. Because we discussed a lot also with Pierre, thinking of how to set up the QISS project, for instance. There's this banal phrase that everything is politics, and it's true. And this goes also for physics, and I don't mean party politics. And I think in general, it would be, I agree with both of you essentially on the main point that policy needs to be discussed more by the people affected by it, which is us, and we don't do that sufficiently. At a community, we don't do that. We do it, but maybe we don't have the impact we should have, and we should think about that. And the other thing is that I wanted to let you know, Pierre, that you will, of course, remain a member of the QISS Consortium as a researcher, but I would like to ask you to join us as an external advisor if you want. We cannot pay you, though, on the policy part and how to structure the project.
Well, that's very nice, Marius, and so I'm happy to accept. I don't really know what I can advise on.
Yeah.
If I can help in something.
That was the trick. You just said yes to something you don't know what it is.
No, yeah, but I'm happy to help to the extent that I will be able to do it in any way. Now, I mean, I really appreciate that you gave me this opportunity to speak one last time. Like, it's a bit emotional also because I've worked with many of you here, and I mean, really, I really enjoyed all the minutes that I had during my time in academia and in physics. And so if I'm leaving, it's not because I've been disgusted by it or not. Absolutely not. I mean, although I'm very critical about the way it's working, I really had a lot of fun, and thanks to all of you. And I'm just hoping that we have time to talk again about physics, maybe not right now, but a bit later when I will have more time.
Carlo wants to say something.
Just one thing, Pierre, we're going to miss you a lot for as a person to talk physics and everything else, but don't hope you're outside the community. You're still inside the community, even if you're doing something else.
Thanks, Carlo.
Thank you all so much. Pierre, all the best with whatever you're doing, and stay in touch. Don't disappear.
Yeah, same for you. Good luck with everything.
Bye, everybody.